Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Chaconopia Whirlwind by Matthias. And here are the rules. We have 1. Chaos construction. The grid has to be divided into 9 regions of orthogonally connected cells. And each row, column, and region has to contain the digits 1 through 9 once each. So an orthogonally connected region means you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So this, for example, would be a valid region. This would not be, because to go from this cell to any other cell in the region, you would have to either go through a corner or you'd have to go through an edge, but go outside of the region to do so. You could also not have something like here, because even though you can connect from each of these cells to each other by going through edges, all while staying within the region, you can't connect to the rest of the region by doing so. So that is an example of how chaos construction rules work. We also have roles, where cells take on roles if certain conditions are met. These roles increase the value of those cells. Only if none of these conditions, which are described below, is met, the value of the cell is its digit. If more than one condition is met, a cell always takes the role with the highest value. I like to put it this a different way. The value of a cell is its digit unless it fulfills the criteria of a role, in which case it takes the highest value role possible. That's the way I like to put it. Anyways, these are the roles. You have role mechanics and values, where x equals the digit in a cell. You have a farmer, where the value is equal to 2 times the digit in the cell. And to become a farmer, a cell needs at least x cells, which is the digit in the cell, including itself, of its own region in the 3x3 area centered on the cell. So, for example, this could be a farmer if this were 4, because you have 4 cells, at least 4 cells in the region, which are in the 3x3 box centered around the cell. So this would satisfy the farmer role for that cell. For a merchant, to become a merchant, there has to be at least one foreign region that occupies at least x, which is the digit in the cell, orthogonally and or diagonally touching cells of the considered cell. So each of these roles is basically, if you think about it, very important, is just basically the 3x3 box centered around the cell. So if, say, we had a region like, can we do this? 1, 2, 3, 4, 5, 6, 7, 8. No. Well, say this was all one region, all one foreign region here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then this cell could be a merchant of up to 6, right? Because you have at least 6 cells that are all in the same foreign region. Now, it could be anything lower than that too, because 1 through 5, obviously, in the 3x3 box around it, you have foreign nations which contain those amounts in this 3x3 area. So that's how merchant works. And then diplomat. To become a diplomat, a cell has to be orthogonally and or diagonally touched by at least x different other regions. So using the same example, this could be 6 as a merchant if, say, you had a region here, a region here. You'd have to have basically a region in a different region in every single spot here, right? So this is one region, this would be another, this would be another, this would be another. Same with this, same with that. So that's how a diplomat would work for this of size 6. And those are all the roles. So remember, if it satisfies multiple of these roles, it takes the highest value role. So if it's a farmer, a merchant, and a diplomat, it would take the role of diplomat. If it's a farmer and merchant, it would take the role of merchant. If it's just a farmer, it would take the role of farmer, obviously. We also have clues, where the value of the cell n steps away in the direction of an arrow is given in the corresponding circle. N is a digit in the cell from which the arrow extends. For example, so there you're going to use example. Row 2, column 2 would be a 3 if row 2, column 2 would be a 3. Then the value of row 2, column 5 must be 6. Because this is saying 3 steps away this way, which would be 1, 2, 3, there must be a cell with 6 value. So this is, remember, the value, not necessarily the digit in that cell. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so the first one we look at is probably the 28. Because to get to a value of 28, it can only be 4 times 7. Which means it must be, or it must have 7 other regions in it. 7 other regions in the 3x3 area surrounding it, which means that has to have 8 regions total to satisfy that. Well, obviously this doesn't work because it only has 4 cells total in that area, so this can't be 4. If this were 3, this would be a separate region. These would all be separate regions, but the problem is that this can't actually get out, so this doesn't work. If it's 2, I think that still doesn't work, right? This is a separate region. This is another region. This is a separate region. So yeah, there has to be a difference between all the outer borders of the regions. So these would all be separate regions. This one can't get out. This one has to go that way, so the light can never be... This one has to go this way, which means the light can never actually work as a region, because it would be only 4 in size at most. So that means this has to be 1. So this is 1, which makes this a 7 as a diplomat. So these are all going to be separate regions. One of these is going to probably have to be pink. So this medium has to go out that way. The green has to go out that way. One of these goes out this way. So we're going to color them, essentially, the outer colors. One of them is obviously going to be pink. We could probably actually make one of these not blue. So I'm going to make this one pink. And we're going to make this, I guess, orange. So these are all boundaries. They have to be. And we don't know which one the central cell is part of. So this has to be 15, which is to become a merchant, there has to be 3 times 5, because that's the only factorization of 15 that works for digits. So these have to be 1 away is 5, and that's 5. So this is yellow, which means at least 1 foreign region occupies 5 cells. So this has to be either red or yellow. Sorry, red or orange goes this way and surrounds. If orange surrounds, I don't think that works. So this one's the same. It goes basically orange surrounds or dark surrounds. If orange surrounds either way, I don't think that works. That means yellow has to go this way, which means red has to go this way. Red would then have to go there. Yeah, I guess that could work. Red would have to go here. Green would have to go this way. That means medium would have to go that way. Dark would have to go this way. Because the problem is this area has to basically fill out 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it could do something like that. And then light would have to go that way. Medium would have to go this way. So then dark would have to go that way. Pink would go... I guess he could do that, so... But it can only do it in one way, right? It can only go that way in one way. Can it be neither orange? And I think the answer to that is no. So if this... Okay, so this is always yellow. So say we had red going this way and dark going this way. Yeah, then that closes off pink and yellow. So orange does have to go one of these two ways. We just don't know which one. Okay, that's interesting. So you could have orange go there. So this is one way. Yellow would have to go that way. Red would finish off there. Green has to go here. Light has to go that way. Medium would go this way. Dark would obviously have to go this way, which means pink would have to go that way. So this is 1, 2, 3, 4, 5, 6, 7, 8. This has to still go out. Medium, so that would be light that way. So that's 9. 1, 2, 3, 4, 5, 6, 7, 8. So this is guaranteed if it goes this way. So red would have to go this way. Yellow would have to go this way. This could not be part of the same cells. Oh, this doesn't actually have to go all the way there. Okay. But it needs at least 8 of them. So light has to go this way. There's no other way. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 at least. 1, 2, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, sorry. There's at least 2 of these are green. You could have all 3 of them be green. This actually doesn't need to be green. Okay, so let's figure this out because this is important. You guys have to go both ways, essentially. So red does... Okay, so this yellow forces this to be yellow. Sorry, this orange here forces this to be yellow here, which forces red to go here. So that's certain. So we know either way, this one is blocked here and this is blocked there. Okay, so how does this work? So again, if we block this way, oops. If we block this way, that means yellow has to go here, and then it has to extend further. Red also has to extend out there. So green is blocked from going this way. Light, that means green can include this. 1, 2, 3, 4, 5. 1, 2, 3 is guaranteed. This could be red here. Red has to extend here though, no matter what. Because green has to take up 9 cells. And it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, because it always has to leave a space open for light. So light has to be going that way, which means, and it has to extend here because, again, you only have one space for light here at most. So that means light has to go there at least, which forces medium to go there. So again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots potentially for green, which has to have occupy 9 of them. Obviously, this one could be green or not green, but there's only one space possible for here, one space possible for red. So that would be one. So this can never be red. So red could go here, or it could be green here. Same with light. So green has to be all of these. Could be all of these. Light can only encroach one this way. So red can be here, light can be here, and that's it. So we have 1, 2, 3, okay, yellow has to go out. So yellow has to go out that way. So 1, 2, 3, 4, 5, 6, maybe 7. This is 1, 2, 3, maybe 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, maybe 8. So therefore this is at least, this is at minimum 9 here. So then yellow has to go that way. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. We have one more here. So this could be red. Either of these could be yellow. Yellow could extend further. 1, 2, 3, 4, 5, 6, 7, 8. And then 9. Or then 9 with one of those two. Light has at maximum 1, 2, 3, 4, 5, 6, 7, 8, 9. Dark always has to go this way. So then dark would go that way. Pink would have to go that way and extend further. Medium, you have 1, 2, 3, 4, 5, 6, 7 at minimum. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this could be the edge. So this is, whoops. At least there. So the light could go one more here. Medium could go many places. So this is how it would be required. So this is that area, right? If we go the other way, okay, so then this could be orange, which would force pink to go this way. It's basically just the reverse of this. So dark would have to go up. So orange would go that way, pink would have to go that way, dark would have to go that way. Then medium is blocked off. So medium would have to go this way. So again, dark could be up to, okay, so we have to figure out this, so this goes that way, so that's done. This goes there. So pink would have to go wrap around. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So pink would have to, okay, let's do the required ones we know. 1, 2, 3, 4, 5, 6, 7, 8, 9 maybe. Okay, so these are definitely required. So we have orange, pink going this way. Has to be to here. Dark would have to go 1, 2, 3, 4, 5, 6, 7, 8. And then it could extend to here. Medium has to be only these possibilities. Light would have to go this way. And then extend 1, 2, 3, 4, 5. 4, 5. Green would have to go this way. And then red would go this way. It would just be that. So red would go there. Yellow would have to go this way. And that should be symmetrical. So those are the requirements of what these regions have to be. Okay. Interesting. This is 18 going this way. So it's either as a merchant times 6 or a farmer times 9. I don't think it can ever be a farmer 9. Can it? This obviously can't be. So can this be farmer 9? So say this was a 9. That means this would block this way. And then this would never have access to 5. So the answer to that is no. It cannot be 9. It has to be a merchant of value 6. Because this would then be a complete region, but this cell would not have the ability to have 5 cells of the same foreign region occupying 5 of the spots in the 3x3 area surrounding this cell. So this cannot be 9. One of these is a 6. Okay, this cannot be 6 because you can't have a foreign region occupy 6 of the cells because that would include its own region or its own cell. So that's not possible. So this has to be the 6, which forces this to be 1 to be in that direction. So this cannot be the orange. Okay, so this can't be orange here. So then it has to go that way. Okay, so let's clear everything, I guess. We know which direction it goes, essentially. Okay, so let's clear that. So again, this is green, light, medium, dark, pink, orange, yellow, and red. So orange cannot go this way, so orange has to go this way. Yellow then has to go this way, and it extends out here. Red must go this way. Green goes this way. Pink goes here. Medium goes here. Light, so green can go, has to occupy at least 8 of these. So it could go here as a whole. Light has to go here, and it could occupy one of these 3. Red can only occupy this because if it occupies that, it would block the green. So red has to go this way. Yellow has to go this way. Red has to go here. So that's 1, 2, 3, 4, 5, 6, 7 again, and 8. So that's required. Yellow has to go here. Actually, I guess yellow doesn't have to go this way. 4, 5, 6, 7. So that's required. So we have boundaries here guaranteed, here and here. Light has to get out somewhere, and we have 1, 2, 3, 4 at most, 5, 6, 7, 8, 9. Medium has to go out, so it has to go this way. Dark has to go this way to get the 5 because orange cannot anymore. If I guess it could, no, can't do both because again, we already showed it can't do both. So this is dark. Medium has to go this way then. So this is guaranteed to be boundary, guaranteed to be boundary. This says a foreign cell, foreign region must occupy 6. So it cannot be dark here, because if this is dark, then the foreign region can only occupy 5. So this has to be a boundary here. It's likely medium. And light cannot go there. So that doesn't. So you could. Okay, can you have a foreign other region? No. So this has to be dark, which covers 6. So I guess it could go 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, no. 2, 3, 4, 5, 6, 7, 8, 9. So it cannot reach this way. So it's likely going this way. This obviously can't be 1. The 1 can't be multiplied by 2. So this is 3 or 4 here, guaranteed. Pointing this direction. This is a value of... This is going to be a diplomat, so this is a value of 4. This has to be a value of 18 again. This could be 1, 2, or 3. That seems fine. This has a value of 3 for one of these two. So this is 1 or 2. Cannot be 1, so this has to be 2. Which means this must be a value of 3. So this is either 1 or 3. It can never be 1, so this has to be 3. So this is a value of 3, which means it cannot be a farmer, interestingly enough. Can yellow reach there? 1, 2, 3, 4, 5, 6, 7, 8, 9. No. Okay, so this is all set here. So these are boundaries there. Boundaries there. This dark has to be all the... And if it goes here... 1, 2, 3, 4, 5, 6 does not work. Because then this can't be part of gray. Cannot be part of any other region. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this can never be dark, which means this has to be medium. This has to cover 6 spots. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So those have to be the dark spots. This has to be medium. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 3 other spots here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this can only occupy 2 more spaces. This dark region can only occupy 1 space. So this must be 1, 2, 3, 4, 5, 6, 7, 8, 9 as a dark. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9 as medium, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 as light. So these cannot be light here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe. So this is not dark medium here. So this is done as a region. This is done as a region. This is, let's go to the boundaries around the entire grid. This is done as a region, and this is done as a region. Okay, this is... So this could be green, pink, or yellow. This has a 6. Red can only go out 1 more here. Yellow can reach 1, 2, 3, 4, 5, 6, 7. So yellow can only go 1, 2, or 1, 2, or 1, 2. So those are the yellows. Orange could obviously be any of these. Or here. It could go here. And then pink could go 1, 2, 3, 4, 5, 6, 7, 8, 9. So pink could technically go any of these spots. Orange could be 1, 2, 3, 4, 5, 6, 7, 8, 9? 1, 2, 3, 4, 5, 6, 7, 8. No. So it can't extend all the way there. So orange can get to here, get to here, get to here. And blue cannot close off pink. Well, technically it could go all the way up to here. Okay, so blue could extend, I think, to here. Well, we'll figure that out. Blue has to touch there. That's a certainty. 3 or 4. I can't see behind this line. 8. Okay. So that's 8. Yeah, let's get some of these lines removed so I can actually see what these are supposed to be. That's one problem with these things. Okay. So this has to be a 3, which means it cannot be a farmer. That's interesting. Cannot be yellow, so it's either orange twice or it's blue twice. If it's orange twice, that means it has to go out as a cross. That's interesting. If it's blue twice, it has to sort of go blue that way, because it can't go 2 that way then. So, okay, so blue cannot reach here. If blue were here, it would have to be either part of the 3, which doesn't work, because then it would have 3 cells in that 3x3 area centered around it, which are in the same region, so that would not be a farmer. So this cannot be blue going this way. Blue could go here. No, this is either orange going this way or blue going this way. So this can't be blue either. Therefore, this has to be yellow. Right? If it's orange going down here, you could have... I guess this could be orange. Can it? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I guess this could be orange also. Okay. Just blue cannot go both ways there. Blue could... Blue, 1, 2, 3, 4. It can't go 1, 2, yellow, orange here, and then this be orange, because then that would be 3 cells occupying. But blue could be here. No, blue cannot be here then in that instance. So this can't be blue either. If this were blue, orange would have to go essentially like this to be part of this. But blue can't be just here, because it would block everything else off. So blue has to go this way, orange has to go this way. If this is orange, so we have 5, it has to go like a cross. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And we could have 1, 2, 3, 4, 5, 6, 7, 8, 9 also. So that could work. So that would be yellow, yellow. This would be red. Yeah. If we had blue go this way, though. Can this ever be orange is kind of the question. I think the answer to that is no. If both of these are orange, this is orange also, right? Because there's no other place for orange. I guess it could go this way, and then pink could go sort of around there. So maybe this could actually be pink. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so that could actually be pink. And this cannot be, though. Interesting. Okay. Hold up. This can't be 3 because this can't be 5. 1, 2, 3, 4 possible at most. This can't be 5. This has to be a 1. So this is 1, which means this has to be a 5 as a merchant. Because again, 15 can only get a value of 15 with 3 multiplied by 5. So the 3 has to be the merchant value, and then the 5 has to be the digit. 5 cannot be here, 5 cannot be here, therefore neither of these can be the cell, so it must be 1 pointing to this. This cannot be orange then. This is pink or blue. This can't be pink because of the pink already there. So this is satisfied, this is satisfied, this is satisfied. This is satisfied. This is not satisfied yet. Neither is this. Neither is this. This is satisfied because it has to be orange. So this cannot be pink. That's interesting. This has to be blue. Pink can't reach it. Orange can't reach it. And yellow and red definitely can't reach it. So this is definitely blue. Three is not completely done, though. This is done. This is done. This is essentially done. This is done. So it must have a 6 somewhere this way. I guess this could be 6 here. So it could be 1 here and 6 here. That's possible. Farmer of 3 works all along here, though. So that works. Okay, so this has to be 1, 2, 3, 4, 5, 6, or 7. So it's 1 through 7 here. This has to be 1, 2, 3, 4, 5, 6, 7 also. It could be, it's farmer of 6. Can any of those actually be farmers of 6? No. 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 So none of them can be farmers of 6. They could be merchants of 4? Or diplomats of 3. Diplomats of 3 is definitely the easiest to be. Merchant of 4 does not work here. Actually, diplomat of 3 doesn't even work here. It touches only 2 foreign regions. So this cannot be either merchant of 4 or diplomat of 3. Because merchant of 4 requires a foreign region to have 4 cells. So this can't be 1 then. How about this one? Merchant of 4 does not work, but diplomat of 3 doesn't work either. You only have 2 foreign regions here, so this can't be 2. This does work though for diplomat. You have definitely 3 foreign regions here in the 3x3. You don't have a merchant though. This is 2, 1, 2 at most, yeah. So it could be 3, but it has to be a diplomat if that's the case. Can it be merchant? No. There's no foreign region that's going to have 4 cells here. It could be diplomat. This cannot be diplomat, and again, cannot be merchant of 4. Can't be diplomat of 3, cannot be merchant of 4. So 5 doesn't work. And then 6 and 7 also have the same problem. Right? So 1, 2, 3. 3 works, 4 works. 5 does not work. 6 does not work. because this can't be a merchant of 4. And it can't be diplomat of 3. This doesn't work either. So 6 and 7 does not work. This is 3 or 4, which means one of these is guaranteed to be 3, but we don't know which, because it's a diplomat of 3. Because none of the merchants actually works as a possibility. Okay, so this is all done. Or not done, but it's basically we figured out the information we got from that. This is done. This is done. 3 and 4, 8 going this way. Which means it could be an 8 by itself, which either of them could fulfill. So 8 by itself is fine. Or it's a farmer of 4. This cannot be a farmer of 4. It only has 3 cells. But this... Wait, this can't be farmer of 4 either. Huh. Okay. So neither of these could be farmer of 4. This can't be diplomat of 2, because it's only one region it sees in foreign region, but this could be diplomat of 2. So we've got some weird thing where this could be 2 or 8, and this could be 8. We don't know. Interesting. Where are the ones in the medium region and the light region? 1 cannot be here in the medium region. So therefore 1 has to be one of these 6 here. And it can't be, it could be here technically. So this cannot be 1 here. Light region also cannot contain this. Light region can't be here. So white 1 has to be one of these 6 cells, which means this can't be 1, and this can't be 1, and this can't be 1. So 1 in the green region must be one of those 3. So this is all done, so we can draw the boundaries around those. So those are done. This is done, so we can draw the boundary there. Well, not completely, so let's not draw that one. This is not done. This is not done. This is done here, so let's draw the boundary there. But this is not done. Okay. Okay, 1 for the red region cannot be here. It has to be 1 either here or here. Cannot be this one because green has to have a 1 here somewhere. Okay. This cannot be pink. 1 of dark has to be there. 1 of pink is one of these. It cannot be any of these. It could be here. So it's we're probably gonna have to figure out this part essentially. So again, this cannot be diplomat of 3. Cannot be merchant of 3 or farmer of 3. So those are all restricted. Maybe we need to look at 5s. Okay. So 5. Okay, yeah, actually that's pretty good. 5 of light is in the first 3 rows. 5 of medium is in the first 3 rows. And 5 of green has to also be in the first 3 rows because it can't be here. So that means the 5 of dark cannot be in the first 3 rows. It can't be in the 4th row, and it can't be here. And it can't be here because of the arrow. So whereas the 5 in the dark, it has to be here. Okay. 5 of the red cannot be here, here, or here. So 5 of the cannot be there, so 5 of the red has to be one of these 4 cells. But where is the 5 in columns 1 and 2? One of them has to be green, one of them has to be red, so this can't be 5 here, or 2. So one of them definitely has to be green. The yellow can never be part of the 5. Cannot have a 5 in column 1 or 2. So it must be red and green, which means the rest of red and green cannot be 5. So this can't be 5 here, which means light has to have a 5 in one of those 3 cells. Because it can't be green, it can't be orange that's here, because it's 2 right now. And this can't be yellow or red cannot have a 5. 5 is there. Where is 5 in column 5? Cannot be light, could be medium, cannot be dark. Obviously can't be pink, could be orange. And any of these two, this can't be though. So 5 in column 5 cannot be here, could be here, cannot be here, cannot be here. Neither of these, this can't be, or so it's basically here or here. Interesting. Oh, interesting. Okay, so say this was, well, then this would not be 5. It could just be here. I'm guessing that the orange probably doesn't work. We could try it out. Right? Hmm. Those are all the digits we kind of have, right? 6 can't be here. So 6 is definitely one of those 3. So light. Oh, that's interesting. Light and medium. Medium already has a 6. Light has a 6 in must be in row 1 or 2. Green has to have then a 6 which is in rows 1 and 2. So that means this cannot be 6. This can't be 6. These can't be 6. So 6 in the dark has to be one of those 3. This can't be 6. None of these are 6. 6 cannot be in the dark. 6 could be in pink, yellow, or red. Okay, let's try this orange as being the non-farmer, non-merchant, non-diplomat. So therefore, it has to go from this angle because it cannot go here because it blocks yellow or whatever. And it can't go here because then there's too many cells here, which are not possible. So that would be orange. Neither of these could be orange here. Where could orange go? It can only go this way. So this would be orange. Pink would go this way. We don't have to end it there. Pink has to go up to here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this can no longer be pink. That's blue. This can't be pink. 1, 2, 3, 4, 5, 6, 7, 8, 9. It cannot block off the blue here. So this is blue guaranteed. This would have to be yellow, yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this could not be yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this cannot be red. We have 9 green, so this can't be green. So this would be pink. I don't know. It's kind of looking like the actual solve path. 1, 2, 3, 4, 6, 7, 8, 9. So this can't be pink or orange. So this is blue definitely. 2, 3, 4, 5, 6, 7, 8, 9 would block this area. So this cannot be pink. So this is both blue. These obviously can't be orange. 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It could go that way. So this could be pink. These are all blue though. This satisfied the no merchant, no farmer, no diplomat part. So this would not be yellow, that's red. That satisfies all of them. Okay. Doesn't seem to be that limited, unfortunately. So obviously this couldn't be 5 in that instance. Huh. Ugh. Okay, that's not that restrictive, unfortunately, as I thought it would be. I don't think this can ever be orange. Yeah, it can't ever be orange. Can this ever really be pink? I don't know. No, it can't. So this can never be pink. Because if we try to make that pink, the problem is the blue has no way to get out. Orange, we showed, only goes that way, right? Can this be yellow? I don't think this can be yellow either. If this is yellow, the problem is that this cannot be yellow. It would have to be orange, but then the orange is blocked off from there. So this can never be yellow. So 1, 2, 3, 4, 5, 6, 7 guaranteed. Could be 8 and 9. Cannot be 8 and 9 here because then this doesn't have a region. So this is definitely blue. So let's try this as blue. If this is blue, this cannot be blue. It's... What the heck? Okay, cannot be blue. So that's pink. That's interesting. Huh. 1, 2, 3, 4, 5, 6, 7, 8, 9. It would have to go this way. So then blue would have to go here? Huh. So this would be pink. Pink, pink. This would block this off. And, okay, yeah, so this cannot work. If this is blue, so red and yellow can't reach this. Pink can't reach this. So if this is blue, it does not work. Orange doesn't have enough cells to form a region because pink has to go this way because this can't be orange because of the orange here. This can't be blue because of the 3 farmer rule, right? It would, if this were blue, it would basically satisfy the farmer rule and therefore would have a value of 6. So this must be pink because yellow can't reach it, red can't reach it. But the problem is to be pink, it has to basically go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9 does not reach it. So then this can no longer be orange. But then the problem is orange doesn't have enough cells that it can be part of. And anyways, this would satisfy the merchant rule here if this was the case. Say it did part and was part here. It would satisfy the merchant rule then here, which is not allowed. So this cannot be blue. This has to be orange. Okay. That's good to know. So this must be orange here. Connects that way. These can no longer be orange. These are both yellow. The orange cannot go here. Cannot go here. It must extend to here and then to here. So this is the only orange possible, which eliminates orange here. This is yellow. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore, this can't be yellow, and this can't be yellow. That forces this red to be full 9, so this can't be red, which means this is green, full green, which means this can't be green. This is pink. We have 1, 2, 3, 4, 5, 6, 7 pinks, which means it can only extend. Let's remove pink here. 7, 8, 9, 8, 9. Those are the only possibilities. So these are all blue. Okay, so we have all our boundaries here. Let's just not get the... so this is done. That 3 is not a farmer, is not a merchant, and is not a diplomat. So this is done too. Oh, wait. 15 has to be merchant. So this must be all pink. Because blue cannot go here. So this can't be pink. Therefore, that's done. So again, this has to be a merchant because 3 times 5, the 3 has to be the multiplier. And the 5 is the value. And the 5 has to have one foreign region have 5 cells. So that's valid there. This is 5. This cannot be 5. Where's the 5 in column 5? It has to be here. So this is 5. Which means this cannot be 5 here. This cannot be 5 here. This cannot point to 3 away. 1, 2, 3. Because then it would be 5 times something equaling 6. 5 times the integer equaling 6, which doesn't work. Okay, so why can't it be 1 away? Oh, because one of these is 1. Okay. Yeah. 5s, remaining 5s. One of these 2 is a 5. That means in column 9, the 5 has to be one of these 2. Okay. Remaining digits in orange region. 4, 6, 7, 8, 9. Okay. Oh yeah, this is done. So that's a region. So 7 cannot be in pink. Does that help us any? I don't know. This can't be 7 because of the 7 in the column. So one of these 4 is a 7. 7 cannot be here, so 7's one of these. Okay, so where is the 7 in the dark region? For rows 1, 2, and 3, we have to have 7s in the green, in the light, and the medium regions. So that eliminates 7 from the rest of the rows 1, 2, and 3. That means dark cannot have 7 here, cannot have 7 here, so this must be 7 here. Okay, so this is not done yet. This is not done yet. This is not done yet. Okay. Farmer of 3. It can be a 6 by itself because but it can't be 6 by itself because 6 cannot be in the medium gray regions. The 1 having to be here eliminates 1 from there. So this can't be the thing. If it's here, it has to be farmer of 3 or merchant of 2, which both satisfy. Farmer of 3 or merchant of 2, which they both satisfy. Farmer of 3, merchant of 2, farmer of 3, merchant of 2, farmer of 3, merchant of 2. So those all are satisfied there. If this is 2, this would be a farmer of 3, but we don't know which one. So we're guaranteed a 2 or a 3 here, but we don't know which one. That's not helpful. Okay, this can't be 1 because of the 1 in the column. Remaining digits in column 5. We have 2, 4, 6, 7, 8, 9. Okay. This can't be 7. This can't be 7. This could be 7. Hmm. Seven cannot be here or here in the medium region. So 7 has to be one of these 4 in the medium region. 6 in the dark region has to be one of these 3. Because it can't be, these are no longer possible. This is not possible. So 6 has to be one of those 3. 6 could be here or any of these. 6 could be any of these. So 6 has to be one of these 4, the green region. Okay. So 1 has to be one of these 2 here in column 9 because we already have a blue 1 and a dark 1. Where's the pink one? The pink one cannot be any. These are filled. Can't be here, can't be here, can't be here. So it must be one of these. So it must be one of those 2, which eliminates 1 in the rest of the column. These can't be 1 either because of the 1 in the column. These can't be 1 because of the 1 in the column. Where's the yellow one? Interestingly enough. So 1 in green has to be here. 1 in light must be one of these 3. Medium has to be one of those 2. Yellow cannot be here. Yellow's 1 has to be one of these. Cannot be here. So it's one of these 4? Okay. Yeah, it cannot be here, but it could be any of these. One of these 2 is a 3. Oh, this can't be 3 because of the 3 in the column. So then this doesn't satisfy the merchant, again, of 4. It doesn't satisfy the farmer of 6. So this cannot be the 3 then, which means this must be the 3. So it's 1, 2, 3, 4 away. So this is 4, which eliminates 4 in the region. So this is 3. Does that tell us anything else? I don't know. 3 cannot be here. It cannot be here. So 3 of the red has to be here. Oops. 3 of red has to be there. Which means, where is the 3 in column 2? It has to be part of green. Where's the 3 in column 3? It has to be part of light. Interesting. Where's the 3 in the medium then? So we know, well, okay, that does not, no, that is not guaranteed. Never mind. We know the 3 in the light has to be there though. 3 cannot be here, cannot be here. Pink has to be one of these 5, but that's pretty broad. Hmm. 2 cannot be here or here, so 2 in yellow is one of these. Ah, where is the 2 in columns? Could be yellow. No. Where are the 2s in red and green? They have to be in columns 1 and 2, which eliminates 2 in the rest of column 1 and 2, so this cannot be 2. So 2 in yellow cannot be here or here. It must be one of these 2 cells here. So this is 2 guaranteed. That means this can't be 2. This can't be 2 in light and medium. So we're guaranteed then nothing. Dang. 2 could be a medium here. That's the problem. We're guaranteed a 2 here. We're guaranteed a 2 in columns 1 and 2 for the red and the green region because there's no other place for it. Hmm. 4 cannot be here. But there's no other restriction on 4s. Anyways, where is 3 in blue? It has to be either here or one of these 3, but that's not helpful. Remaining digits in column 8. 1, 2, 3, 7, 8, 9. This cannot be 1. It cannot be 3 here. This can't be 2, excuse me. 1 is one of these. This can't be 1. These can't be 1 either. 7 is one of these 2 or one of these digits here. This 3 eliminates 3 here, so that's 4. Okay, so that's helpful. There we go. So this 3 eliminates 3 here, so it's 4. It points to this. We can remove everything but 8, I guess. And 7. No, not 8. 7. Everything but 7. Therefore, this cannot be a 2. No, it cannot be a diplomat of 2. Because it's only seeing one foreign region. So this has to be an 8. So that's 8, which eliminates 8 in the rest of the column. That's interesting. That forces 8 to be one of those 2 cells there. These 2 cells are exactly the same as those 2. Okay, so this is satisfied. This is satisfied now. We can fill out those borders. This one's not done yet. So that's the only one. Okay, so 8's one of those 2, so this cannot be 8. Remaining digits in the dark region. We have 2, 3, 6, 8, 9. So obviously these can't be 6. This can't be 6. 2 has to be one of these 2 digits. We're not sure which. So if this is 2, this can't be 2. If this is 2, neither of these can be 2. So neither of these can actually be 2. This can't be 7 because of the 7 in the region. So this could be 7 here still. Remaining digits of column 4. We have 1, 2, 4, 6, 8, 9. Obviously, none of these can be 2. Because one of the yellows 2s has to be here. This can't be 1. This can't be 1 because of 1 in the row. This can't be 4 or 8. 1 is one of those 3. These 2 digits must equal those 2 digits, but that's not that helpful. 5 cannot appear in the rest of the light region. Neither can 3. Is that helpful? I don't know. How many 7s do we have? Not enough. Actually, well, no, 7 could be here too. We are guaranteed a 7 here because none of the rest of the column can contain a 7. So this is guaranteed to be 7 here. Oops. Which means this cannot be 7. 4 can't be here. 4 can't be here. So 4 has to be one of these 3 cells. 4 could be here for the pink, so that's not guaranteed there. 4's here. Huh. So 4 in medium has to be one of these. Okay, this can't be 4 because of the... This can't be 4 because of the 4 in the region. 4 can't be here or here. 4 could be here in medium, though. 4... Oh. Where's 4 in the green, red, and yellow regions? They have... Well, okay, where's the 4 in the first 3 columns, should I say? It has to be part of green, red, or yellow, because light already has a 4. So, that means 4 cannot be here in the yellow region. It could be orange, though. So this is orange or medium. This is orange or pink. This could be orange, pink, or medium. Or blue. Yeah, okay, so that's too many possibilities. Okay, row 5. We have a lot of limitations there. We have 2, 6, 8, 9 as the only possibilities in row 5. Unfortunately, that's still not good enough. This can't be 2 because of 2 in the column. Okay, so we also know 2 can't be here, so 2 has to be one of these 3 cells, which eliminates 2 here. Okay, so what is eliminated here? Okay, so we have 1. It cannot be 1 because 1 is guaranteed to be one of these 3. Right? Right, because there's no other place for 1 except for green in row 4. So this can't be 1, which means the light in row 1 has to be here. 2 has to be one of these 3, so this can't be 2. You could have a 3, but you can't have a 3 here. So this could be 3, no 4. 5 is possible. 6 is possible. 7 and 9. 3, 5, 6, 7, 9. So this has to be 3, 5, 6, 7, or 9 to match. And this can't be 5. 2 away can no longer be 2. Well, if it's 2 away, that can't be 2 anyways. It cannot be 3, though, either. So this cannot be 2 away. This is 4, 6, or 7. 4 away could be 2 or 3. 6 away could be 2 or 3. 7 away could be 2 or 3. Okay. One of these 3 is a 6, so these cannot be 6 here. Okay, remaining digits of row 4, we have 1, 2, 3, 7, 1, 2, 3, 4, 8, 9. Obviously, this can't be 2 because of the 2 in the column. 3 again has to be one of these 3, so this cannot be 3 and this can't be 3. I think that's it, right? Hmm. Uh, uh, no, 7 has to be one of these 4. Hmm. Hmm. Okay. Remaining digits in the pink region. We have 1 through 4, 6, 8, or 9. Obviously, one of these has to be a 1, so this cannot be 1. This... I don't think we have any other limitations. That's not good. Hmm. Remaining digits in yellow. No, we have 1, no 2, no 3, 4, no 5, 6, 7, 8, 9. So 1 cannot be here. Do we have any other limitations? No, not particularly. Three cannot be here. 3 is one of these 3. 3 is one of these 3. Oh. No, that's 4. Never mind. Never mind. Hmm. 8 is one of these 2, so this can't be 8. That's not helpful. Oh, where's the 2 in the dark region? It has to be one of these 3 also. And then we have 1 out of 3, 8, or 9 here. So this cannot be 2 here. Where is a 2 in the medium region? It has to be one of those 3. Huh. Interesting. Not too helpful, but interesting. We have 1, 2, 3, 4, 5 regions. That's not helpful. So one of these is a 2. One of these is a 2. Ah! So one of these is guaranteed to be 2 here because it cannot be here. One of these 2 is guaranteed to be 2 here because the yellow has to have a 2 here. It cannot have anything for it because the red and the green 2s have to be these cells. So that means none of these can be 2. So this is 2 for the yellow, which means 2 in the mediums has to be here. 2s in the darks have to be here because either this is 2 or this is 2 in column 5. If this is 2, that eliminates 2 from these cells. If this is 2, that eliminates 2 from these cells, so these can never be 2. So darks 2 has to be one of these cells, which means where's the green 2? Can't be here, can't be here, can't be here. It has to be one of these 2, which eliminates 2 from this cell, which means this has to be a 2. So that means 6 has to be one of these cells, so the 6 cannot be here. So this is 8 with 4 or 9 here. We're not sure which. Therefore, 2 cannot be here. 2 cannot be here. 2 is one of those 2. 2 could be any of these. This could be 2 also. Not too helpful. Yeah. We already know the 2 could be any of these. Um, but there's no guarantee. We know 1 and 2 have to be 2 out of these 3 cells, but we don't know about the remaining digit. These 2 cells must match these 2. Um, these 3 cells must match these 3. So we have what? 3. It cannot be 3 here. It could be 4, 6, 7, 8, 9. Yeah. Okay. These 4 cells must match. These 5 cells must match these 5 cells there. Obviously, this can't be 2. You could have 3 here. 4, 5, 7, 8, 9. Yeah. Oh, interesting. No, no, never mind. Thought we found something, we had not. Okay. Yeah, this is the only arrow we have left. Not helpful. Hmm. Yeesh, yeesh, yeesh. What else am I looking for? This is basically just a lot of irregular Sudoku. But I'm not finding very much information here. We need more restrictions, but I don't know what those could be. I mean, we've already restricted things a lot. We only have one more roll thing to go, and that's not a lot of information. Oh, this can't be 6 because of a 6 in the region. Does that help? Probably not. Yeah, 6 could be here or either of these two. Oh, that's kind of interesting. How many regions are here? We have 1 yellow, 2, 3, 4. 4 regions which must contain a 6, all in columns 1 and 4. So that means the rest of these cannot be 6. So 6 is either here or here. 6 has to be one of these 3. And then 6 could be any of these cells here. But this cannot contain 6. Obviously, this couldn't contain 6. So what are the remaining digits in these light regions? So we have 1, 2, no 3, because we have to have a guaranteed 3 here. No 4, could be 5, cannot be 5 in any of these spots. Actually, 5 has to be one of these two, so can't be 5. Can't be 6, could be 7 or 9. Oh, that's actually very limiting. Interesting. So 1 cannot be here, 1 cannot be here. The rest is... This can't be 7 because of the 7 in the column. This is actually really restrictive here. That's interesting. This could be a lot of things. 1, no 2, 3, no 4, 5, no 6. Do we have 7 restriction? I think so. Where can 7 be in red, green, and yellow? They have to be in columns 1, 2, and 3. So this cannot be 7 here, which means these can't be 7. So 7 has to be one of these two. That's interesting. So we're guaranteed a 7 in one of these cells. Oh. Interesting. Oh, no, it could be here. So it could be 7 here, 7 here, or 7 here. Right, so this cannot be 7 here. Because red, yellow, and green all have to have 7s in columns 1 through 3. So that leaves no 7 available for the light region. So 7 has to be one of those two. 7 could still be one of these 4. 7 in blue has to be one of these sets. 7 in orange is obviously one of those. Okay. Oh. No. Let's just double check these, but I'm pretty sure we've satisfied. So 7 must be a diplomat. We have 1, 2, 3, 4, 5, 6, 7 regions which are in the 3x3 area surrounding that cell. 15 has to have 5 cells of one foreign region surrounding it. It does. Same with this one. It has 5 cells surrounding it. This must be a non-farmer, non-merchant, non-diplomat 3. No farmer, because it's 2 cells. No merchant, because these are 2 cells each, and they touch only 2 other regions. So that's satisfied there. This must have 5 cells surrounding it, which it does, of a foreign region. This must be just an 8. This has to have at least 6 cells surrounding it of a foreign region, which it does. So yeah, we were all done with those. It's just this one. And this could be 2 or 3, but it just so doesn't really don't have very much information there. Let's look at remaining digits in this row. 1, 2, 3, 4, 7, 8, 9. Okay. Neither of these can be 1. This can't be 4. Yeah, that doesn't really help us much. Interesting. Okay. Hold up. Okay. Where are the 4s in the medium and the green regions? They have to be in rows 2 and 3. Because it can't be in 1. Obviously, medium is only in rows 2 and 3, but what other 4 can be in rows 2 and 3? It has to be in green. So this cannot be 4, which forces this to be a 4 here. That's interesting. That means 4 cannot be any of these cells. None of these cells are 4, so we have a 6, 7, 9 triplet here. Which means this cannot be 9. This becomes a 4, 8 pair here. Which eliminates 4 and 8 in the rest of the row. But that doesn't really tell us too much. Gives us some information, I guess. It's just, yeah. Just not too much, though. Well, this is not too helpful. Uh, well, whatever digit is here has to be one of these 3 digits in the gray region, in the medium gray region. 4, 5, and 7 match these. So 6 is one of those 3. Okay. Well, that doesn't tell us much. Oh, it does tell us something. No, it doesn't tell us much. Never mind. Never mind. No, we didn't get enough information there. Because this is possibly a 4. This is possibly 4 with those possibly 4s. Remaining digits in row 7. No 2, 4, 5, or 8. So 1, 3, 6, 7, 9. This can't be 1 because of the 1 in the box or the region. Yeah, not very limiting. This is becoming just a very hard this is becoming just a very hard regional or sorry, irregular region Sudoku. I'm not the best at these either, I will say. I'm just, yeah. This can't be 7 because of the 7 in the column. That's not helpful. Oh, wait. One restriction. Uh, for this cell. Okay, I need to double check these restrictions. Now this is times 3, so that's fine. This is never gonna have diplomat of 5. Um, this is 8. That's fine. This is never gonna have diplomat of 6. And we already figured out this restrictions here. So this restriction, the 3 cannot have a merchant value of 3. But it still could be a farmer value, a merchant value of 2. Ooh. Huh. Can this actually be merchant value of 2? Yes, here. Right. This, okay, so if it's 4 away, this would have to be, the merchant value would be for 3 and above. So this would have to be a farmer of 2. 6 away, this would also be a merchant value of 3. So this could not be 3, it's 2. And this could be a farmer value of 3. So the only place where you can have a farmer value of 3 is here. And every case can also have a merchant value of 2. But these two cases would have merchant values of 3, which means that 3, if you tried to have a merchant value of 3 here, it would not work. But we already know 2 has to be one of these cells. So that's not that helpful, unfortunately. Yay. Oh, interesting. One of these 2 digits is a 6. But that doesn't really help us too much, does it? I don't know. Not really. Hmm. Yeah, this is just your regular Sudoku, which I'm not that great at. I'm very good. Well, not very good. I'm decent at chaos construction, but irregular region Sudoku, I've done a decent amount, but these are not very easy to spot. Um, they've got some interesting quirks to it. Yeah, so we just basically showed that 2 has to be one of these 4, but we already knew 2 had to be one of these 4, or really these 3. And that doesn't really help us much. We just know it can't be... can't be farmer 3 for these 2 cells. This could be farmer 3, though. But the thing is, it's still not restrictive, right? This could be merchant 2, right? Or not merchant 2. Yes, it could be merchant 2. So farmer 3 can only be here. Merchant 2 could be any of those 3. Uh-huh. Yeah. Not too helpful. Hmm. Yeah, I don't know. It's just not that restrictive. Hmm. This kind of sucks. Hmm. Yeah, all the cool stuff is done, and you basically just have to use irregular Sudokus to figure this out. And I don't like doing irregular Sudokus. I mean it's fine, but it's just I don't know. Obviously, one of these two is a one. We don't know about two. We don't really know about three. Uh. Hmm. I'm gonna pause. I need to go to the bathroom right now, so I'll be right back. Let's pause and pause. And I'm back. Okay, let's continue. We just have to solve this irregular region Sudoku. Uh, so these 4 digits must be the same as these 4 digits. Okay. Is that helpful? I don't really know. I'm not sure if it is or not. Um, hmm. The problem with this is definitely it can be any of them, right? Force because 2 is satisfied as a merchant here, here, and here. 3 is satisfied as a farmer only here because it would be a merchant everywhere else. Um. Oh wait, diplomat. Diplomat. These would all be 2 diplomats. Ah, okay. Right, because they're touching 2 other regions. This would be a diplomat too, it's touching 2 other regions. This would also be a diplomat too, so none of those can be 2. So then this has to be 7, because the 3 is only satisfied as only a farmer. This is merchant 3, merchant 3, merchant 3, and this is the only one that is not merchant 3. So this has to be merchant 3. So this is 7. This is the merchant 3, which eliminates 3 in the rest of the region, the rest of the column. This can't be 3, which eliminates 3 in the rest of row blue, except for this cell. So this is 3, which eliminates 3 here. This becomes an 8-9 pair, which eliminates 8 and 9 in the rest of the row. So this can't be 8 or 9, this is 1. This can't be 8 or 9 or 1, so it's 2. This can't be 8, 9, 1, 2, so that's 3. This then becomes a 6 because of the 8-9 pair in the region. This is a 3 because of the 8-9 pair in the region. That 3 eliminates 3 here. This 3 eliminates 3 in the rest of the row here. Where is the 3 in column 3? It must be here. So this is 3. So that's actually very important. Yeah, so that's 3 as a farmer. And it cannot be 3 as a merchant. And that was a key. And 2 as a diplomat was the case for every single spot here. So now we are done with all the rules. So, now it really is just irregular region Sudoku. So this was the break we had to have. So it wasn't just irregular Sudoku. 3 cannot be here or here. So this is 5, 6, or 9 here. This 7 eliminates 7 in the rest of the region and the rest of the column. So where is 7? Where's 7 in column 1? It has to be red region. That means the 7 in column 3 must be the yellow region. Because the light region has to have the 7 in row 1. None of these can be 7. So because these cannot be 7, where is the 7 in the gray region? It has to be here. That's 7 there, which eliminates 7 in the rest of the column. We have to have 1 and 3 here because there's no other place for 1 and 3 in column 8. So this cannot be 3 in this pink region. Okay. There is no... Okay, so 5 has to be one of these two. So therefore, where is the 5 in column 3? Again, the 5 in yellow, there's already a 5 in yellow. The 5 in column 1 and 2 has to be then in red and green, which means the 5 in column 3 has to be light. So this is 5, which means none of these are 5. This is 7. Okay. That means 5 is one of those two, obviously. Now this is irregular region Sudoku. So now we have to be able to figure that out from what it's okay. Oh, where's the one in column 9? Can't be in the blue region. Now it can't be in the medium gray region, so it has to be here. So this is 1, which eliminates 1 here. Therefore, we have a 6-9 pair in the light region. That eliminates 6 and 9 in the rest of the light region. This can't be 9, so it's 2, which makes this 7. 5 is here. This 2 eliminates 2 here. We have a 4, 2, 8, 9 quadruplet in the medium gray region. So that forces this to be 1. Therefore, this cannot be 1 here. Okay. This can't be 1 anymore. This can't be 1 anymore. Where's the 1 in row 9? It has to be one of these two. So this cannot be 1 here. Obviously one of those is 3. This can't be 2 because of the 2 in the column. This 2 eliminates 2 here. Okay. This 6 eliminates 6 here. Where is the 6 in this blue region? It has to be one of these two cells. So this must be a 4-6 pair here. Which means the remaining digits in the region are 2, 5, 7, 8, 9. And where is the 2 in this column 9? It has to be one of these. This can't be 5. So one of these 3 is a 2, which eliminates 2 in the rest of the region. So this can't be 2. This is 8 or 9. This is a 4-6 pair, which eliminates 4 and 6 in the rest of this row. That means, where's the 4 in the red region? It has to be one of these cells, and it cannot be here. So 4 has to be one of these two, which eliminates 4 in the rest of the column. So this cannot be 4. Whereas the 4 in the green region, it can only be here. So this is 4, which eliminates 4 here. Therefore, 4 is one of these two cells. We don't know which. 4 is in one of these two cells, and it must be one of those two cells, which eliminates 4 in the rest of columns 6 and 7. That eliminates 4 here, so this is 8, which makes this 4. Where's 4 in column 3? It can only be in the yellow region, because this is 4 is eliminated by the 4-6 pair in the row, and this has a 4 in the row, and this has a 4 in the region. So one of these two is a 4. We also know one of those two is a 7. So this must be a 4-7 pair here. So we have a 4-7 pair here. That eliminates 4 and 7 in the rest of the region. It also makes this 6, 8, or 9. It cannot be 6. So it's 8 or 9. We have a 2, 6, 8, 9 quadruplet in the red region, which eliminates 2, 6, 8, 9 in the rest of the region. This cannot be 6 or 9. Therefore, that leaves what? 1, 3. Okay, so 1, 3, 4, 5, 7. And this can't be 4. This can't be 7. This can't be 5 here. These can't be 3. Okay, we can remove sort of the outer boundaries. One of these is 1, so this cannot be 1 here. That makes this a 5. So this cannot be 5 here. Where is the 5 in row 1? It has to be here. So this is 5. We have a 6, 8, 9 triplet in... Okay, that eliminates 5 here. One of these has to be 8, so this cannot be 8 here. Okay. This 5 eliminates 5 here. It also cannot be here. Where is the 5 in the blue region? Can't be here, can't be here, so it must be here. That's 5. 2 is one of these 2. We don't know which. 7 has to be one of these 3. Okay, so we should have all the 5s. 1, 2, 3, 4, 5, 6, 7, 8, 9. We do have all the 5s. Okay. Where's the 2 remaining column 2? It has to be here. So that eliminates 2 here. Okay. 1s. 1 cannot be 1 and 3 cannot be here because of the 1, 3 in the row. This can't be 3 because of the 3 in the row. So where's the 3 in the pink region? Well, it could be either of these two, unfortunately. So is one of those. We have a 4, 7 pair in row 8, which eliminates 4 and 7 in the rest of the row. Not too helpful. Where is this digit in the blue region? It has to be here. So we're going to mark this as A. And this has to be the A. This is the B, then that corresponds. B has to be one of these. Oh, we have an 8, 9, 8, 9 pair in row 9, which eliminates 8 and 9 in the rest of the row. This can't be 8 or 9. This has to be 2. Yeah. That eliminates 2, 8, and 9 in the rest of the row. So this can't be 2, 8, or 9. So this is 7, which makes this 9, which makes that 2. This 9 eliminates 9 here, so it's 8, which makes this 8, which makes that 9. This 8 eliminates 8 here, so it's 9. 7 eliminates 7 here, so it's 1. This can't be 1 anymore. This 9 eliminates 9 here, so it's 6, which makes this 8, which makes this 9. 6 eliminates 6 here, so this has to be 6 here, which forces this to be 9, which makes that 6. This cannot be 8 here. This can't be 8 here. We have a 2, 9 pair, which in column 8, which eliminates 2 and 9 in the rest of the column. This 9 eliminates 9 here, and 9 here, and 9 here. This can't be 2 or 9. This becomes a 1, 3 pair here. 2 eliminates 2 here. Oh, this 9 eliminates 9 here, so this is 2. This can't be 2 or 9, which makes this a 6, 8 pair, which eliminates 6 and 8 in the rest of the row. This can't be 6, no 6 or 8. Yeah. This 2 eliminates 2 here. This can't be 9 because of the 9 in the column, so this is 8, which makes this 9, which makes that 8. That eliminates 8 from the rest of these cells here. This 2 eliminates 2 here, so it's 9, which makes this 4, which makes that 2. This 8 eliminates 8 here, so it's 6 and 8. This 6 eliminates 6 here, so it's 4 and 6. This 6 eliminates 6 here, so it's 1, which makes this 9. This can't be 6 or 9, so it's 8. That means this can't be 8 or 9, so it's 6, which makes this not 6, so it's 9. Which makes that 7, which makes that 6. 1 eliminates 1 here, so it's 3 and 1. 7 eliminates 7 here, so it's 4 and 7. This can't be 4, 7, so it's 3, which makes this 7, which makes this a 4. Huh. Interesting. Yeah, I was wrong here. This was not, when we didn't have this solved, that was not because we couldn't, it was not going to be solved by irregular Sudoku. It had to be solved by that clue. So it's a good thing we looked at that clue again. Particularly about, yeah, sometimes it's easy to lose track of which roles can also not work, right? So that is, I guess, one thing that you have to keep in mind with these Chaconopia puzzles, is always being to figuring out what restraints we have, right? So I found out that none of these could be 2 in value to satisfy this clue, because they would all be diplomats there, because they're all seeing 2 separate foreign regions in all of those positions. So it had to be the 3 farmer, which satisfied that. And everything cleaned up once we cleared that out. So anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.